In this video, I'm going to give a quick overview of Spring Cloud Kubernetes. A little bit of a sales pitch here is that I have made a training course on Kubernetes. There are links in the description below if you're interested in that. That's the sales pitch over already. But one thing I wanted to do on that course is to make it kind of programming language independent. So we do a lot of work with pre-existing images on that course, and we never really go into the implementations of the microservices that we're deploying. But on the latest update of the course, I've just covered ConfigMaps, and ConfigMaps are a really good way of sharing common data, properties usually, across an entire architecture. And this has a particular value in microservices in that we can easily share common global variables across the whole system. We don't want too many of these common globals, of course, because shared data is always dangerous, but realistically, you always need some kind of shared common data. If you are here as a Spring developer, you're probably aware of Spring Cloud Config, and I explain on that training course that something like Spring Cloud Config is really duplicate functionality that you can also get from ConfigMaps in Kubernetes. So the choice would be yours as an architect really as to whether you use Spring Cloud Config or whether you use ConfigMaps. But if you are using ConfigMaps, there is one big downside of a config map, and that is if you change the config map in Kubernetes, at the time of recording at least, those changes will not be picked up automatically by any dependent pods. So I go on the training course about how you've really your only option is to bounce the pods, restart them in other words, which is very awkward. So one of the features of Spring Cloud Kubernetes, which I think has been an incubation project for a while, but now appears to be a first-class project in the Spring Cloud project. And there's not a lot of information on the official spring.io page, but as always, you'll find a lot of information on their GitHub page. There are a few features, not that many features in Spring Cloud Kubernetes, and I imagine it's going to grow over time. Their objective is to make it easier to integrate a Spring Boot application with Kubernetes. Now, I'm not going to do a full tutorial on this. I'll assume if you're watching this video, then you're capable, then you're familiar with Spring and you'll be able to use the reference manual yourself. I will show you a sample project in a few minutes and go through the changes I've had to make, but it's the usual job of adding dependencies into your POM. And there are really two big headline features of Spring Cloud Kubernetes. First of all is you get a discovery client. And so that's the equivalent of what you might have been used to having from something like Eureka, in that we can discover services automatically. Now, up until now, if I switch into my Java code here, this is the sample application that we build on the training course. If you're not familiar with it, there'll be a link in the description below to my GitHub repository, so you can clone this if you want to play with it. As an example, in this Fleetman API Gateway project, I seem to recall that I am calling other services in the cluster. And I'm using feign, which if you're familiar with that is a way of calling REST services without you having to do any HTTP type stuff in your code. And the interesting thing is on line 13 here, where I'm having to point feign at the URL of one of my microservices. So that's quite fiddly, really. I guess I must have configured that in the properties, in source main resources. Here's the properties file. And yeah, I've had to be aware of the Kubernetes URL of that service. So Fleetman-position tracker is the name of the service in Kubernetes. I didn't actually need the default SVC, etc., but I've put it in anyway. And the purpose of the discovery client then is that these services will be found automatically. Now, I'm going to admit that I have not, at the time of recording, had a chance to try this out. I will get around to that at some point, but my assumption is this is going to work in the same way that Discovery Client worked for Eureka. So, going down a little further, it's really the Kubernetes property source implementation that I'm interested in here and that I'm going to demo on this video. Two wonderful features of this really is that if you've set up a config map in your Kubernetes cluster, you can point your Spring Boot application at that config map and it will automatically read in all of the properties in the config map, and they will become part of your Spring Boot application, which is absolutely fantastic. So it means that, and for the demo, the big one I'm going to be doing is I'm going to be showing you we have this microservice called Position Simulator, which is sending messages to a queue. Now, if I look in the properties file for that, previously I had a property called fleetman.position.queue, and I had to manually sort of hard code it right here. As I'm saying in the comment here, if we're using the Spring Cloud Kubernetes, then it will automatically go and read it from the config map. So not a big deal here with one property maybe, but if I had 100 properties in that config map, then they'd all be read in and I wouldn't have to add any further lines into this properties file. There is a bit of a downside there. It makes this a little bit harder to reason about. If I'm just looking at this project, I can't see at a glance what properties I'm going to be reading in from the config map. So I would have to go and look at the config map to work that out. So bear that in mind. A lot of this is pros and cons, and that's a definite con of using this approach. But the other fantastic feature of Spring Cloud Kubernetes is, where is it? Let me highlight here. It will trigger a hot reloading of the Spring context if changes are detected on the config map. That is absolutely fantastic. So if we decide for any reason to change the value of fleetman position queue on the Kubernetes cluster, this application can be configured to auto-detect that. It will either restart or the program will just end. And of course, in a Kubernetes environment, that's a perfectly good approach, because if this ends, assuming your pod is managed by a deployment in Kubernetes, then the pod will just be restarted again and will load in the changed config map. If you want this hot reloading, you do need to add some properties to make that happen, and that's what these three values are here. I won't go into laborious detail on this, but you can check the manual out for details on how all of this works. Spring Cloud Kubernetes.reload.enabled needs to be set to true. The default for that is false. So slight downside there, that I have to make sure in any of my Spring Boot projects I would have to have those 3 lines of config. I haven't had to do a lot of work, a few config changes, and in the POM, in any POM that's going to be reading from the config map, I've added in this dependency of Spring Cloud Starter Kubernetes-config. So off camera, I've already built these projects and I've pushed them as images to Docker Hub. Now, I've already got lots of images on Docker Hub for the training course, and obviously I can't touch the training course images. So I've created special images for the position simulator and the position tracker, and they're tagged with ConfigMaps demo. So if you're coming here from the training course, you are well aware that we have a YAML file containing all of our pod definitions in the form of deployments. If you're not here from the training course, then I'll provide a link where you can get all of these YAML files. If you're following along, then you can try this out for yourself. You just need to find the position simulator deployment and change the tag to ConfigMaps demo. Go a little further down to position tracker and change that one to ConfigMaps demo. If we apply those changes, at first we're going to get a disappointing result. If we do a watch on kubectl get PO, here's my simulator and here's my tracker. Actually, I've had these running for a while now, and can you see that it has restarted that pod 18 times, which doesn't look normal to me. Now, I'm sort of waffling here because I'm waiting to see if, yeah, there we go. Can you see the simulator and the other one has now gone into an error state? And after a few seconds, I think it's going to be, yeah, now it's gone into a crash loop back off. So what's going on here? Well, there's 2 problems we need to solve. The first one's a little bit tricky. The second one is just the obvious problem that we haven't actually set up a config map yet with the data that we need. But let's solve the nasty problem first of all. kubectl get PO, and I'm going to look in the logs of one of those containers. So either will do. Let's go for the position simulator, and yeah, big Spring Boot crash. And yeah, there are 2 stack traces in here. The first one ploughing through it, is cannot resolve placeholder fleetman.position.q. That's good because we haven't created that value in a config map, so we can solve that easily. But going much further up, there is a slightly more worrying problem here, which is Kubernetes client exception, failure executing a get, blah, blah, blah. It's saying that the user system service account default cannot get resource pods in the API group. So this is an RBAC problem, role-based access control. If you're not familiar with that, then I can recommend a very good training course available in the link below, where we talk a lot about role-based access control. However, one thing I didn't go into a lot of detail about on the course was service accounts. Now, a service account is like a user. In fact, it really is a user in Kubernetes, but it's not a human user like the ones we were doing on the course. These are users that are internal to the Kubernetes cluster. And what's happening is the Spring Cloud Kubernetes code is saying, I would like to do some operations, please, on the cluster. And I'm going to do that as the user called, and it's the user that we have here. And this is actually the default service account. But if I can cut to the chase, all this means is we need to create a cluster role and a cluster role binding that is going to say, for the service account called default, we are going to give them some privileges. And those privileges I've created in a cluster role called Spring Roles, and they're here. And I'm just saying that for pods and config maps, I'm going to allow Spring to be able to get, list, and watch config maps. And that makes sense because, of course, they're going to have to read in the data from config maps. They need access to pods as well because of some operations that they're performing at startup, but it's really the config maps that are important. So as before, if you're confused about any of this, then do check out my training course. I said I wasn't going to make this a sales video, didn't I? Naughty me, never mind. But again, this file will be available in the link in the description below. Oh, by the way, I've called this file service account for Fabricate access purely because it was the Fabricate project who originally wrote the Spring Cloud Kubernetes code. They've absorbed it into the main Spring project. So that means then I need to do a kubectl apply on this file, service account for Fabricate access. So that's one of the jobs I need to do. But of course, the other job is I need to create a config map holding my global data. I won't bore you by typing that out. It's a regular config map in Kubernetes. I've called it global qconfig. And if you're following along, you will need to call it global qconfig as well, for reasons I'll show you in a second. And the data inside this config map matches that variable that my microservices are expecting to read in. I've just realized one thing I haven't told you. The name of this config map is global qconfig. I haven't shown you how the project code is configured to look for that config map. And all I've done is I've created a bootstrap properties file. You might be familiar with bootstrap files in Spring Boot. They run before the application is started. And that's where I can say that I'm going to get all of my config for this microservice from the config map called global qconfig. And it's fine to provide multiple values in here. So with all of that in place, both this microservice and the position tracker should be picking up this variable called fleetman.position.q, and therefore they should be consistent. Let's try it then. I need to do a kubectl apply on the fleetmanglobals.yaml file. And what should happen now is on the next time this pod is restarted, I'm hoping it's going to run successfully. Just to keep things clean, I think I'll delete both of the pods just to force, I forgot to put pod in there, just to force everything to start from a clean sheet, and we'll get those restarts reset back to 0. I don't think we actually, I'm fairly certain we don't need to do that, and we'll just check they've started up okay. Okay, So they are running and have been running for about 30 seconds. I'll just wait a short while. In fact, I'll put a watch on that. All right. Well, I'm not seeing any errors there. So the proof will be in the logs. Let's do a kubectl logs. I'll do a -f on either of them. Let's go for position simulator. Looking a lot better this time. I do have debugging on this because I did have some problems getting this up and running, but there's no stack traces in there. And let's have a look for import. This is the important line of logging. Located property source. It has found our global queue config, and the properties inside are fleetman.position.queue is set to the value of position queue. Fantastic. And if I go all the way down, I'm looking for the line here, which is saying it has added a watch to ConfigMaps. So it's that's going to detect changes to the config map. We should have a similar log in the other microservice, the position tracker. We'll take that as read just to speed up the video a bit. But what I'm really excited to check out is, can we make changes to that value and the changes get automatically picked up? Well, here I am on the front end for the system. So this is on a node port of 30,080, and you can see that the system is happily ticking away and the vehicles have started moving. But I've also got a node port set up for port 30,010, which gives me access to the Activemq Console, so I can manage the broker. You might need the password of admin and admin to get here. And if I click on queues, I should see wonderful. That's the name of the queue that was picked up from the config map. And I can see that the simulator is sending to that queue, because if I keep refreshing, the messages enqueued is going up. But I can also see that the position tracker is also reading from the queue, because the number for messages dequeued is going up as well. So that's good. But now the big question is, if for any reason, I don't know why we would want to do this in real life, but for some reason we decide we need to change the name of that queue. Now previously I would have had to go into all of the images and change those hard-coded values and do a rebuild. I could have passed the queue name in as environment variables, but even then I would have had to go to every single YAML file that's using the queue name, and I would have had to change each one in turn. But now we have the data in one place, and we hope that any changes here are going to be automatically picked up by the system. So let's see if that's true. Let's change it to "has this changed?" I'll save that, and I'm not entirely sure exactly what I'm going to look at in the demo. I think I'm going to apply this file and then very quickly recall the log command here, and I want to see the log tick over when it detects a change was made. That's the plan. If you're watching this video, then the plan works, because if it doesn't work, I'm going to bin the video and pretend this never happened. So kubectl apply -f on fleetmanglobals.yaml. Hold your breath and very quickly get into the logs. Wow, actually I haven't done a thing. That was very quick. It's already ticked over. And I can tell you that that time is basically now. I'm expecting the first thing I'll look at is, yeah, if I look on the front end, the app is still running. Now, for those of you new to this, there is an ugly little bit of my system that the simulator, well, it is just a simulator. It's reading from a built-in file. So when it restarts, the vehicles sort of teleport back to the start point and you get these ugly lines bouncing across the screen. Maybe I'll fix that one day, but the important thing is I can see that the app is still running, the vehicles are still updating, but the real proof will be here in the queue page. I'm going to do a refresh, and this is wonderful. I can see there is a new queue, and most importantly of all, I'll keep refreshing here. Can you see? Yeah. The messages enqueued and dequeued is going up for the "has this changed" queue, but the old position queue is now just abandoned. I'm not saying it's a great idea to change queue names on live running systems, and there is an obvious problem here. I know many of you will point this out in the comments, that there is a race condition. If the simulator has sent a message to the queue, and then we do that change. I think there's a very good potential that if the position tracker, for example, picks up that change first and switches to the new queue, but the position simulator hasn't quite picked up the change yet and it's still sending messages to the old queue, I think there's a very good potential that we are going to lose some messages. Well, we won't actually lose them. They will still be in Activemq, but they will be sat there pending and will never get consumed. So there is a race condition there. Depends on your application as to whether you care about that. And as I say, probably really wouldn't want to be changing queue names on a production system, but we have proved that it's possible to do it. Let's do this one more time. I'll do a second change and apply that file, and I won't even bother looking at the logs this time. I'll just keep refreshing, and there we go. And I didn't do a video edit there. That was just in the time I was talking. And I don't know if you noticed, but there was a stack of 38 pending messages. I just saw through the corner of my eye there were 38 pending messages on this new queue, which meant that the simulator picked up the change before the simulator. If it was the other way around, then we would have had some abandoned messages on the old queue. I don't think that's a big deal. The demo proves that Spring Cloud Kubernetes is capable of dynamically picking up changes from ConfigMaps, which is a fantastic feature. Maybe one day that might become a built-in feature of Kubernetes, and I know there is work underway to do that. If you've come this far, then I hope you found that somewhat useful. There's a link in the description to all the files below, and if you've not been on my course, then I might see you on that. All the best.